We are here for the SIGGRAPH in Latin America, Brazilian meeting. And this year, we want to celebrate our presence on SIGGRAPH. We Brazilians, we are here for a long time. We not started here now. The mascot from SIGGRAPH this year is from Mario. Last year, the best PhD thesis is from Eduardo. We do not start now. We have a long history, as Professor Marcelo Zuffo showed to us. And I am part, I'm much more younger, like Manuel, Marcelo Zuffo, but I'm also part from the history. I am part for IRC since 2030. For SIGGRAPH Asia, I am part for Symposium Education Committee. And now I am member of the council, ACMW, that's Council from ACM to Women. And we start with Professor Marcelo Zuffo, that was chair for International Resource, and he talked to us about the works here, International Resource, and also the works, the presentation that he's doing this year.
So I was not expected to talk. My name is Marcelo Zuffo. How many people here speak English? So I will speak English then. Well, I'm located in São Paulo. São Paulo is not so beautiful like Rio, right, Rejane? So we belong to University of São Paulo there. We have a virtual reality center. This year we are bringing some contributions in the field of VR. So we had designed a VR globe, a crystal sphere. And please check it out. The demonstration will be in the emerging technologies. We also bring Mario Nagamura. He's our designer. And Mario's achievement was designing the SIGGRAPH character. There is a rumor that's a self-portrait. You can check by yourselves. Thank you very much.
Now we continue with Mario, that works with Professor Marcelo, and he talk about what makes him create his character.
I work as a graphic designer and digital designer, and I work on the VR lab of Marcelo. And you know, every year I saw our team working hard to come to SIGGRAPH to present our results, and they are always very excited to show our work. And I knew the spirit when they opened the contest of the spirit of SIGGRAPH. I knew I had a good idea of what it felt like. And then I proposed a character design to capture all this excitement and the innovation that when we walk around in the conference we see. And I made this character, and I helped with the 3D model too. And it's really great to show, and the people are liking. Very glad. Thank you.
This year, the art gallery was created. It was about the Latin American arts. And you have a very interesting work. And you invite a presenter to talk about the work and to talk what made her to do this.
Hi, my name is Gisela. I work in partnership with Leandro Lima, who unfortunately couldn't be here. And I'm very lucky to be selected to present this work at, taking out the mouse from to present this work at the art gallery that I hope you can see it upstairs. The idea behind this was to make an art piece, a video piece that could talk about time. So it actually worked as a clock, where the couple represents the minute hand and the child represents the second. So every time that the child makes a full round, the couple goes forward 1 minute. So now we have the minute, which is 45 minutes, and if I keep talking here for 15 minutes or so, the couple will be up there. And then we use a special lens that back in 2010 was something nice and new, that could do like VR movies, which was a lens, Go Pano, that you put attach it to the camera, and the image was recorded like this, a round image, a circular image. And this was used back then. I feel a little bit like a dinosaur now, because the technology has evolved so much. It was used for you to sense the space, so you could have a sensation of a 306 degrees of a place where you were. And we as an artist, we are always joining technology and concepts and somehow subverting it a little bit in order to create pieces that, yeah, it's this. Thank you.
I invite Flávio to talk to us about the course that they open in Federal University of Santa Catarina.
Hi everybody, my name is Flávio. I'm from Brazil as well, and from the Federal University of Santa Catarina. It's way down south, and we created, started last year, a new course that is called a Bachelor of Animation. So I'll tell a little bit about us. I'm from the city of Florianópolis. That's a photo of our city. It's famous for these beaches. It's an island, and we also have this university. It's a federal university. It's a really large university. We have 284 courses now, and we have now enrolled 45,000 students. And I'm part of the Communication and Expression Center, and inside of the center is the departments. Our department is called Graphic Expression Department, and the origins of our course is have from 2009 to 2011 a course called Animation Design that have 20 students every semester and 4 students every year. It changed to just a design course from 2012 to 2015, and it merged 3 courses that we have. It was graphic design, animation design, and graphic design. And so from 20 every semester, we had 60 every semester. And it was like a general course where we had some projects, like it was like minors, like it was like a major in design and a minor in animation. That's not how it works in Brazil, but it's kind of like it. The problem was that the student getting the university just for the design course, and it wasn't they could choose animation, they could choose each one. So we kind of lost that that student that really wanted to work with animation. If we were lucky, we had someone that wanted to do animation, and it really depended on the year. Every year it changed, so it was really hard to get a focus on animation. So we started the project of to separate the course, and we have succeeded, and we created. It started last year, 2016, the first class, and we tried to look and how should we call this new course. And in Brazil we have some universities that have visual arts, animation, movies and animation, and we try to create something new. And this is the very first course that we have there. There's just animation. We try to focus on it. So we have 20 students every semester, again, 40 students a year. And our course is based on 3.5 years minimum, divided in 7 semesters. All universities in Brazil usually work in a semester. So the first year you have the basic classes, and the second year and third year have specific projects, what they call mandatory disciplines and what they call elective disciplines. So the mandatory is what they must do, and the elective, they choose part of those, which one they want to do. So, as I said, in the first year, it's divided in the first and second semester. We call the basic. I didn't put all the disciplines that I have here. It's just like the basic focus that we have. So, have drawing, you have color theory, you have art history, you have semiotics, and some other courses. And we try to focus on drawing. Even we have a great focus on technology, we still think a good foundation drawing is really good for all the students that want to work with animation. So when they go to the second year, they start the projects. So in the third semester we created what we call a pre-production project, and have this structure of one major project. There's a discipline, and have 4 other disciplines that are complementary to the main project. So this one we created is those disciplines is character design, sound design, video editing and composing, and screenplay. And when they go to the second year, the fourth semester, they have another project, the 2D animation project, where we have concept art, environment design, more drawing, focus on 2D animation, and a proper 2D animation discipline. In the next semester, they go to the 3D animation project, where they have 3D modeling, digital sculpture, 3D animation, rendering. Just go back, just so you know, we are now, since we started last year, the first students that got into this new course, they are now in this stage. They are now entering their third semester. So we still haven't had these next ones that I'm showing. Just to you know, this is my area. I used to be a 3D animator. I work as a generalist in Brazil. As most of guys in 3D animation works as generalists in Brazil, so we have to go to all the basic aspects. So I've been through all of these areas, and now my focus is on motion capture and game design that are related. So when they go to the third year and sixth semester, they have some other mandatory disciplines, and that's when they start to. There's a time without a project, without a main project, where they go to internship, and they have the time to do the elective disciplines. So just a list of some of the disciplines that they have. So one of the mandatory have some management disciplines, so they can arrange their, try to arrange the pipeline, try to learn pipeline, try to develop the management of the whole animation process. We have a discipline of motion capture, have some focus on games, and since we are in the graphics department, the communication art and art department, we don't have the coding side of the gaming, so we focus more on the art and the design. And they also have photography and visual effects, and we have a series of elective disciplines that they may choose one of them to do. Some of them are more focused on the drawing, like character and animation for web. We have this called animated series, where we try to teach them how to create an animated series. There's a great focus for a great opportunity to create animation in Brazil. Also some other related to management and motion design. So in the 4th year, they go to their 7th semester, where they can create their final project. So our idea is that we teach them the basics of 2D animation, 3D animation, and when they go to the final project, they gather in groups and create one big project to finish their course. So we still haven't had anyone getting to this point yet, but we're expecting them to create something really good, because we already have this background experience with the design, animation design that we had, and I'm still teaching in the design course with the 3D animation project, so we're still working on it, and we try to create something that is not what I think is the ideal, it's not the perfect one, but we created with all the resources that we have now. So sometimes in Brazil we create new courses, and then we go after the funds to hire professors to build new buildings. And the good thing about our new course is that we have everything already set, and we have all the professors. So the total class time that you have to finish this, to get this bachelor, it's 2,790 hours total. And from the elective disciplines, they have to complete a minimum of 270 hours. And we have now 16 teachers in this course, and we have classrooms, of course, and laboratories. So I just want to show a brief of the laboratory I work on. It's called Design Lab. We have workstation, 3D cameras, 3D printers, and the focus of my area is motion capture, as I said. So we created this new studio. It's a really large one. It's a multi-user studio. That's why we have this green screen. The green screen is not used in the motion capture. It's just the idea is when not motion capturing, we lift the system and you can use the green screen. We built this thinking about an expansion. So we now still have only 16 cameras from Vicon. I don't know if you know Vicon system. They are here at SIGGRAPH. It's one of the major players in the motion capture area. And the total space is 25 meters by 15 meters. So it's really large one. Vicon told us the largest in Latin America. But for this 16 camera, we use just a smaller space. And we have projects and funds trying to expand the system. This is one great thing about it. It's that whenever you get more funds, you can add more cameras and expand and increase the resolution and increase the quality. And this studio started working, the system came in 2013, and this studio was ready this year. So we moved it, and we're already using it, and it's fully functional. we're also open for anyone that wants to use and go there, just create an extension project. And we basically use the Vicon system that is already just to deliver an FBX file, and this FBX file we go through Motion Builder, and from this you can deliver to any software, any like 3ds Max, Maya, Unreal Engine. So it's a full production system that we have, and the students can use it, and also it's open, as I said, to other universities and other companies that want use it. We use it through the extension program, as I said. So, as I don't have much time, so just this is the building that we have for, that's where is the student side. It also have a workplace and a sound studio and a dressing room, and it's a complete infrastructure. And it's separate from the main building from our university, so we can control who goes inside, and we also can use outside the hours that university is open, like we can go in the weekends and so on. So thank you for your attention. If you wanna know a bit more about our courses, the website's animação.ufsc.br. Thank you. Any questions? No? Later? Okay.
And now you have our results last year that make me feel really, really happy. Last year, Brazilian Eduardo, he won the prize of Best Patented Thesis, and the advisor, Professor Manuel, is here, and now is Professor Eduardo. We talk to us about the work.
Okay, so hello everyone. So I'm Eduardo. I'm a professor of computer science at the Federal University of Rio Grande do Sul in Brazil. And I'm going to talk to you a little bit about the computer graphics work that we do at the Federal University, me and Professor Manuel, that we have presented here at SIGGRAPH for the last 6 years. So first, our university, Federal University of Rio Grande do Sul, is in the city of Porto Alegre, which is the capital of our state, which is the most southern state in Brazil. The university in total has over 27,000 undergrad students, 9,000 graduate students, and over 25,000 professors. We are located in the Institute of Informatics inside the university. The Institute of Informatics has about now 1,000 undergrad students. We have 300 graduate students, and we have already graduated over 250 PhDs and 1,400 master's students in computer science and computer engineering. So inside the Institute of Informatics, we have the computer graphics group, which in total we are 9 professors working on the medical visualization, interaction, image processing, fluid simulations, and we have about 50 students at the moment. And the Institute of Informatics is also heavily involved in the Brazilian Computer Society. So the headquarters of the Brazilian Computer Society is located at the Institute of Informatics, and we also have professors involved in the council. So the president, the administrative director, and one member of the council are professors from the Institute of Informatics, respectively Professor Lisandro Granville, Professor Renata Galante, Professor Rosa Vicari. So the Brazilian Computer Society has every year has a contest for best doctoral dissertation and also best master thesis. So this year the first and second place for the best PhD dissertation went to two theses developed at the Institute of Informatics. So the first place went to Eduardo da Cruz, that's advised by Professor Felipe Navor, and second place went to André Grau, who's also a professor now at the Federal University, and is my colleague, my roommate. So, and last year, the work that I did during my PhD, advised by Professor Manuel, won the first place in the Brazilian Computer Society doctoral dissertation contest. And like we just said, we also got the inaugural ACM SIGGRAPH Outstanding Doctoral Dissertation Award. We are very happy with that, because the work was fully developed in Brazil, our university. So now I'm going to show you a little bit of the presentation I gave last year about this work, and then at the end of the talk I'm going to show a little bit of the work that we're presenting this year. So my PhD dissertation was entitled Efficient High-Dimensional Filtering for Image and Video Processing. I was advised by Professor Manuel, and it's about image filtering. So filtering is a fundamental operation in image processing. And simple filters that work on the 2D domain of the image can be used for several effects, such as edge detection and artistic effects, such as texture simulations and among many other effects. But several important applications require filters that work on higher dimensional spaces. And these include, for example, edge-aware smoothing, noise reduction, and also, for example, detail enhancement of images. All of those require high-dimensional filters. And also, there's many other important applications that require, as building blocks, a high-dimensional filter. So, our contributions from the last years were two novel approaches for efficient high-dimensional filtering. We had the domain transform that has a geodesic response that we call, and the adaptive manifolds that have a Euclidean response. So the domain transform was the first geodesic filter working on high dimensionality at arbitrary scales in real time. And the adaptive manifolds was the first Euclidean filter with linear cost on the number of samples and dimensionality of the space. And we also had a third contribution, which was a novel approach for filtering non-uniformly sampled signals. And with that, we showed the first geodesic evaluation of arbitrary recursive filters. So the differential in our contribution, our work, was mainly that all our filters have real-time performance, optimal complexity, being a linear time complexity in the number of samples and dimension of the space, and they're still among the fastest filters on both CPU and GPU for many applications. So we can do effects such as smoothing, stylization, recoloring, tone mapping, detail enhancement, all that in real time on full high-dimensional Full HD videos and images. So quickly, a few examples of interesting applications. We can do, for example, stylization. I have an original image on the left. We can simulate like a pencil drawing effect using our filters. We can also do detail manipulation. So this flower here has some fine details that you can't actually see in the image on the left, which is the original image. We can enhance these details and make it more visible without introducing the visual artifacts on the image. We can also do interpolation, for example, and I have here a grayscale image where only 3% of the pixels have color information. So we can also use our filters to propagate this information for all pixels of the image, and we can reconstruct the full color image from only 3% of the color samples. We could also do denoising for rendering. So real-time rendering, usually you don't have the time to get a good render, noise-free render, but you can actually get some noisy render like this in real time. So what we did is we actually render an image like this one that is pretty noisy, and then we apply our high-dimensional filter to reduce the noise and generate a very smooth shading for the global illumination model. And this is a high-dimensional filter because the filter is using not only pixel information like color information, it uses geometric information like 3D position and normals, etc. So this is the work that we presented at SIGGRAPH in 2011, 2012, and also Eurographics 2015. And now I'm going to give you a glimpse of the work we're going to present this Thursday, which is spectral remapping for image downscaling. So it's Thursday at 10:45 at room 152. And the idea behind downscaling is that usually you have an image that's very, there's a huge number of pixels. Our cell phones can capture 10 megapixel images. But the screen where we're showing that image usually doesn't have that much pixels. So you have to reduce the number of pixels to show the image. But an image usually has some spatial frequencies, high frequencies, that actually may not be representable when you reduce the number of pixels. So for example, if I have this t-shirt with a lot of stripes, and I want to reduce its size, for example, to show it on a web page or on Facebook or your cell phone screen. For example, if I take the image and only discard some pixels to obtain a smaller number of pixels, we get that aliasing effect, where you can see here that we get some stripes on the collar of the shirt that didn't exist in the original shirt. So that small image is not a good representation of the large image. Of course, there's better approaches to do that. There's a classic sampling theory that says that to avoid these aliasing artifacts, you should actually then discard the high frequency details. So usually what happens on your cell phone or on computer screens is that if you have a large image and you reduce it, you're going to discard all high frequencies. So in this example, you can see that the stripes from the shirt have completely disappeared. Here's another example of aliasing. I have here a chirp image. That's basically, it has a lot of high frequencies. It's a radio wave that propagates from the center of the image. We have low frequencies in the center of the image and high frequencies around the border of the image. Again, if I do some subsampling to reduce the number of pixels, you're going to see that the small image does not represent the large image. Okay? So there are several techniques that work that do image downscaling, but they all have problems with this kind of high frequencies. For example, subsampling and perceptual-based downscaling, they generate aliasing artifacts. They generate like new centers for the radio wave that didn't exist in the original image. And other approaches simply discard all of the high frequency details, so you don't get that radio wave propagating from the center of the image. So our idea is then to perform a pre-processing of the image, such that any of the downscaling techniques can actually represent the original image. So on the right you see the spectrally remapped images where we applied our approach to the original image and then downscaled the image using the same techniques, and as you can see we were able to preserve the radio waves from the original image. Here's a more complicated example. This image where the legs and the scarf and the tablecloth, you can see there's a lot of fine details. The screen doesn't have enough pixels to actually show all the details in the image. So, like I said, our technique is a pre-processing step. We don't actually reduce the number of pixels, but what we do is we change the frequency of the details from the image. So you can see we change the number of stripes on the cloth, we change the number of books on the shelf on the background, such that when we get this spectrally remapped image and apply any downscaling technique, it can actually still preserve the high frequency details, and unfortunately this monitor doesn't have enough pixels, so you can see that. If I compare now a bigger version there, you can actually see that our work on the left there, with green preserves the stripes on the cloth, and the same filter applied without our pre-processing actually discards all details from the image. So I have to acknowledge our sponsors that helped us during all this time, and people that provided feedback, images, and code. And I hope I see all of you Thursday morning to learn more about details from this new technique. Thank you.
It is really great, beautiful results. All the results are really great. And we have been invited to Professor Marcelo Zuff to talk about, he has many beautiful works, to talk about the works that he presented at SIGGRAPH.
So the meeting is a little bit more formal this year, so I apologize for that. So my institution recently is the CITI, the Interdisciplinary Center for Interactive Technology. Centro Interdisciplinar para Tecnologias Interativas. It's a really different model at Brazilian universities. We have funding for the next 20 years. The funding is completely open. So the idea behind is try to create in Latin America a long-term think tanks where we can go beyond the current limitations or the current constraints of local funding agencies. So recently, University of São Paulo started to rank in between the best universities in the world, but we still need to do a lot to do high-impact research in that part of the globe. So because that, the university had created these think tanks, and we are one of these selected by the university. So we belong to USP, is also a large university. We have around 100,000 students. We are ranked amongst top 100 universities in the world. And particularly came from the electronics department at the School of Engineering, the Polytechnic School. So what's the vision of CITI? Recently we had discovered that humans show up around 300,000 years ago. So we have a center to do research innovation in human-computer interaction. Why that is relevant? We came from here. What the guy is doing here? Fire? A tool? No, he's programming. He's programming a hardware. He's trying to inject an object, an abstract object, on a physical hardware. So in the past 300 years, we move his light from here to here. And the only difference between these two pieces of hardware is the von Neumann machine. So the center envisions that in a few years we'll have thousands of computers per human. So a fundamental problem on humanity will be how computers and humans relate to each other. So that's our scientific question in the long term. We want to fix this question in the next 20 years. So we have currently around 60 researchers, but we are an interdisciplinary center, so we can approach anyone at the university. So I will talk to you about quite interesting projects where we are collaborating with the veterinary school, the School of Archaeology. Here's some application domains. So that are the schools that already we are collaborating with. The School of Education, the School of Medicine, Odontology, Physics, Mathematics, Archaeology. So it's some of our projects. Humanity is getting smart, but is also getting old. Many people imagine that Brazil is a young country. That's not true anymore. We'll be probably the oldest country in Americas. For several reasons, the birth rate in Brazil decreased dramatically, much more than US. And we do believe that eventually we can compete with Canada to being amongst the oldest countries in Americas. So we need to design a lot of technology to support these people. So we have a strong program on accessibility, and accessibility through digital means. So we are collaborating with organizations like W3C, and we're looking how to design the new generation of accessibility tools for elderly people. And the second project is on crowds. You know that recently, due to political situations in the country, crowds start to go to streets. We have in São Paulo, on a given day, 1.4 million people in streets. So no accidents. So we want to understand why. So we start to do a real-time crowd simulating. And this project is a partnership with UNC in Chapel Hill, with Professor Dinesh Manosha, sponsored by Boeing Company. We have a huge STEM program there. We are reaching already 55,000 professors and 35,000 schools in Brazil. And we offer online training for these professors for STEM abilities. And every year we grab everyone together on a national science engineering fair where we attract something like 15,000 people. This program is being sponsored by Intel Brazil. One of our most radical programs is on cyber archaeology. So in partnership with Duke University, last week we just reached the achievement of connecting both universities in 100 gigabit per second. And we are looking to use this total bandwidth to do real-time deep learning analysis on archaeological sites excavated in Brazil. Here's part of the project. So, let me see if I can do that here. Okay. I hope so. Yeah, we have Duke University with a 6-side cave, an USP cave that is 5-side. We connected both caves by 100 gigabit per second, and we're using LIDAR, laser interference 3D scanning, to do massive excavation, digital excavations of archaeological sites there. So every excavation, digitally, we acquire something like 1 terabyte of data. And with this data, we put everything together and we try to find archaeological evidence using computing models. And the answer is yes. We start to discover new archaeological material from this evidence. And we have some folks from MIT here, and we just recently started a cooperation with MIT on this. We are trying to look for what we call language fossils with the teams of Professor Noam Chomsky. So here's some evidence of our archaeological sites. And in the end, we put everything on virtual reality. So that was our demonstration last year at SIGGRAPH. Some of our early results using state-of-the-art virtual reality, and then we're able to investigate these archaeological sites by virtual reality means instead of traditional VR. Another project that we had displayed last year was our contributions to the field of high maintenance risks. So we have collaborations with the Brazilian Navy, more recently with the US Navy, high power energy companies, the mining industry, and we have a team of researchers designing high risk virtual reality training materials. We just deployed the first system a month ago, and that will become a company. And again, this product has been displayed at the VR Village last year here at SIGGRAPH. And finally, this year we are showing Orb VR, our spherical display. So we are working this for the past 4 years. So 2 years ago at SIGGRAPH on the emerging technologies, we have displayed this sphere. It was a big one, like these Pilates spheres, you know? They are fixed we had used 12 projectors. So very fancy, very complicated to model and stabilize it. And in the past 4 years, since we are engineers and electrical engineers, we start to shrink it. And this year we come out with a very small form factor sphere. And I promise to you that in a few years, you'll have spheres to the size of a ping pong ball, like a crystal small ball. So just to finalize, I will show you the video of that. Just a second. The video is very short. It's in here. Oops. I need to understand how to transfer the video. Okay, here. It's okay?
SIGGRAPH 2017 Emerging Technologies. VR seamlessly combines the images projected on multiple calibrated high-performance laser pico projectors inside a translucent sphere. Both users and VR are position tracked so that the display renders perspective-corrected images. We currently use active shutter glasses to provide stereoscopic depth cues. Alternatively, the same glasses can provide multi-user support with monoscopic vision. We iterated through many designs and prototypes in order to make VR robust, highly compact, lightweight, and capable of supporting direct interaction techniques for multi-participant experience. The interaction with VR can happen via traditional interaction devices, such as 3D pointers, or by simple direct handling. With natural and intuitive gestures, users can inspect a model or see the model VR, moving and rotating the device, or even shaking it like a snowball. VR supports Unity game engine, so currently developers can easily design and run VR games and applications in a frictionless process. Just drop RBVR script on the scene camera, configure the desired radius, and it is ready to go. As the hardware evolves, we envision several possible applications in the interactive 3D visualization field, such as design reveal, puzzle, physics-based and tabletop games, telepresence devices, avatars for AI assistants, and much more. We will continue to improve this technology in order to make it more feasible, desirable, and viable.
Thank you very much.
First time that you are recording SIGGRAPH Latin America Brasilia meeting, and this time is to celebrate our presence here. This is just some of our works. We have other Brazilian presenters. We have other amazing works. Then thank you so much for the presenters. I am Aruca Peixoto and part from IRC, and I hope to see you again next year for our Brazilian meeting. Thank you.